Good morning, students. I am Abisha, Assistant Professor in the Department of Biomedical Engineering from Emmanuel Arasar JJ College of Engineering. Okay, students, today we are going to learn a new topic about series and parallel connected independent sources. Okay, students, first we are going to know about what's meant by an independent source. First, what is meant by sources in the circuit? It's nothing but the voltage or the current that is used in a loop. When we will say that it is an independent source. If the current or the voltage in each planar circuit containing only the dependent source, that is, if the voltage or current in one loop does not depend on the voltage or current in any other loop in the circuit, then we say that it is as an independent sources. These independent sources will be connected in series and parallel connection. Then if there is a some cases are there when this voltage source and the current source are connected in series and parallel. First, we are going to see about the voltage sources in series. That is, in voltage sources in series, the sources will be with same polarity. Here, this is the first case. Here, the voltages V1 and V2 were connected in series, which is having the same polarity for V1 and V2. So we can rewrite the we can rewrite the above circuit as V is equal to V1 plus V2. That is, we will sum the two voltage. Next, in the second case, considering a two sources V1 and V2 with different polarities. So the voltage differences occurs here. Here the polarity depends only on greater of two sources. Here the two conditions were applied. If the voltage V1 is greater than V2, then we get a positive output. That is, V is equal to V1 minus V2. And next, there is a second condition. If V1 is less than V2, we get a negative output. That is, voltage V is equal to V2 minus V1. And the third case for the voltage source is the voltage sources are connected in parallel. That is, two voltage V1 and V2 in the figure are connected in parallel. If the voltage sources are connected in parallel, which is having the same value and same polarities. If two voltage sources are connected in parallel, then it can't calculated because we know that voltages must be same in parallel circuit. So we can rewrite the circuit V1, V2 when connected in parallel. We can write as V1 which is equal to V2. This is all about the voltage sources. Then we are going to see about the current sources. Next is the current source connected in parallel. When the two current source I1 or I2 connected in parallel with same direction, that is here the current is increasing in both I1 and I2, we can rewrite the circuit as I is equal to I1 plus I2. And next case, when the two current sources are connected in parallel with different direction. That is, current I1 is increasing and the current I2 is decreasing. So, in this case, when I1 is greater than I2, we can write as I is equal to I1 minus I2. And the next figure is showing I1 is increasing in current and I2 is decreasing current. So here I2 value is greater than I1. So we can rewrite the circuit as I is equal to I2 minus I1. Next, we are going to study about voltage division in series resistive circuit. First, consider one circuit where the resistor R1 and R2 are connected in series across the source of volt V. When the two resistors are connected in series, the current flowing through both the resistor is same. Then we are applying the Kirchhoff voltage law. We will get voltage V is equal to sum of current across resistor R1 and re current across resistor R2. From the above equation, we can find the value of I as I is equal to V by R1 plus R2. So, the total voltage applied is equal to the sum of the voltage drop across the resistor voltage across the resistor R1 and R2. Voltage across the resistor R2. So, we can write the voltage across the resistor R1 as V R1 is equal to I into R1. By substituting the I value in this equation, we will get the voltage across the resistor R1 as R1 by R1 plus R2 into V. Similarly, we can write the equation for the voltage across the resistor R2 is equal to I into R2. Here also we are substituting the value of I as V by R1 by R2, R1 plus R2. Then we will get the voltage across the resistor R2 as R2 by R1 plus R2 into V. Okay. Next we are going to see a problem related to when the voltage across the three resistors are connected in series. Here, R1, R2 and R3 resistors were connected in series with a voltage source V of 60 watt. So, when the three resistors are connected in series, so the current I can be written as I is equal to V by R1 plus R2 plus R3. So we know that the value of V is 60, R1 is 10, R2 is 20 and R3 is 30. By substituting the above values in the current equation, we will get the value of current as 1 ampere. So, from the question, we have to find the voltage across the each resistance. First, we are going to find out the voltage across the resistor R1. V R1 is equal to, we can write as according to Ohm's law, V is equal to I into R. So, for the resistor R1, we can write as V R1 is equal to I into R1. Okay. So, by substituting the I value in this equation, we can write as V into R1 by R1 plus R2 plus R3. So, substituting the V and resistance R1, R2, R3 value in this equation, we will get the voltage across the resistor R1 as 10 watts. Similarly, we have to find the voltage across the resistor R2. So we can write as I into R2. Then we know that V into R2 by R1 plus R2 plus R3. Okay. So by substituting the values of V and the resistance value, we will get the voltage across the resistor R2 as 20 volt. Similarly, we will find out the value of voltage difference across the resistance V R3 as I into R3. By substituting the I value, we will write as V into R3 by R1 plus R2 plus R3. By substituting the values, we will get the voltage across the resistance R3 as 30 volt. Next is the current division in parallel circuit of resistance. Here in the circuit, the resistor R1 and R2 are connected in parallel across the source of voltage V. Current through the resistor R1 is here considered as I1 and the current across the resistor R2 is I2, where the total current IT is written as I1 plus I2. So we know that current across the resistor, current I1 is equal to V by R1, and the current to the resistance 2, I2 is equal to V by R2. So we can write as V is equal to IR1, which is equal to IR2. From that above equation, we can find out the value of I1 as I1 is equal to I2 into R2 by R1. Substituting the value of I1 in the total current equation, that is IT is equal to I1 plus I2. In that, we are substituting the value of I1. From that, by solving that, we will get the value of I2 as R1 by R1 plus R2 into IT. Now, we know that I1 is equal to I1 is equal to IT minus I2. That is, from the total current equation, IT is equal to I1 plus I2. From that, we are writing the value of I1. So, this I2 value will go to this side, equal to this side. So, it becomes minus I2. So, we are writing I1 is equal to IT minus I2. By substituting the value of I2 in this equation, we will get the I1 value as I1 is equal to R2 by R1 plus R2. Okay. Next, we are going to see a problem related to the resistor connected in the series. The question of this problem is find the magnitude of total current through R1 and R2 if resistor R1 value is 10 ohm and R2 value is 20 ohm and the voltage is 50 volt. So, in the question they have given resistor R1 value was 10 ohm and the resistor R2 value was 20 ohm and the voltage across the resistor battery is 50 volt. So, when the resistors are connected in series parallel, so the equivalent resistance across two resistors is written as R equivalent is equal to R1 into R2 by R1 plus R2. So, the value of R1, R2 are given in the question. By substituting the value of R1 and R2, we will get R equivalent as 6.677 ohm. Okay. Similarly, we have to find for current total current. For current, how we will write I is equal to V by R. That is V by resistor of total equivalent resistor, that is 50 by value of R equivalent is 6.67 volt. By substituting the value, we will get total current IT is equal to 7.5 ampere. As per the current distribution, when they are in parallel circuit, we can write as for the current across the I1 can be written as I1 is equal to IT by into R2 by R1 plus R2. This equation, this formula we have derived in the above circuit. That is, when the capacitance are connected in series, what's the current across the resistance R1? This is the formula for that. By substituting the values of total current R2 and R1 value, we will get I1 as 5 ampere. Similarly, for I2, instead of putting the resistor R1, R2, we are writing R1. That is, we will be writing as I2 is equal to IT into R1 by R1 plus R2. By substituting the value, we will get 2.5 ampere. Okay, so it can be verified that the total current is equal to I1 plus I2. Okay, okay, students, that's all about today's class. Thank you and have a nice day.